Russia's Very Landscape, Physical Processes at Work, Part 2. Here's what you missed in geography. Last time we talked about English scientist named Isaac Newton, and he's saying that, hey, that we can use satellite images to study the Earth. What? That's super awesome. We talked about what kind of physical processes shape Earth's landscape, like tectonic movement, volcanic activity, erosion, and glaciation. Specifically in the last episode, we talked about tectonic movement shaping Earth by making earthquakes and making mountains, and that's so crazy. And we talked about it in Russia specifically. We also talked about volcanic activity and what kind of things make up magma and what kind of things make up lava and how that explodes and it shapes the world, and also specifically Russia. In this episode, we're going to be talking about erosion and glaciation specifically in the world and then in Russia as well. Part 6, how erosion shapes the landscape. Hope you got all that. Landslide. A hill starts to move, sending dirt, rocks, and trees tumbling down its slope. If you lived in a house at the bottom of the hill, you would probably view this event as a terrible disaster. A geographer, however, would also consider it an example of how erosion can shape the surface of Earth. Erosion takes place everywhere on Earth through natural forces, such as wind, moving water and ice, and gravity. All of these can wear down the land around us. Wind erodes land by picking up tiny grains of dirt and carrying them to distant places. This process wears away the layer of soil that covers Earth's crust. Winds can also grind away rocks and hills by blasting them with gritty sand and dirt. Moving water also shapes the land. For example, rivers can carve away at the surrounding land to create deep V-shaped valleys. The faster a river flows, the more soil it is able to wash away and carry downstream. Along coastlines, ocean waves can wear away the shoreline to create steep banks and cliffs, and furthermore, they can erode soil at the base of the cliffs, causing the land above to collapse. When this happens, homes built on the cliffs may similarly collapse and slide into the sea. Glaciers are another force of nature that reshapes the land. The weight of these enormous masses of ice exerts pressure that causes them to travel slowly downhill. As they move, glaciers gradually carve out valleys and create new landforms by depositing rock and soil. Over time, glaciers can transport huge quantities of rocks and soil debris over great distances. Gravity is a constant force on the landscape. Anything that is not well-rooted or attached to the ground will eventually give in to the force of gravity and move downhill. This downhill movement can occur so slowly that we may not even be aware of it, or it can occur quickly, as in a landslide or a mudslide. On flat plains, water can build up as well as wear away land. After heavy rains, rivers overflow their banks and flood the surrounding plain. When a river returns to its bank, soil carried by the floodwater is left behind on the floodplain. This fresh layer of soil makes floodplains suitable for farming, but the floods that create floodplains also make them dangerous to live. In this picture down below, it shows us the sources of erosion. Wind, water, ice, and gravity all cause erosion. We just read that above. Wind moves soil from one place to another, moving water and ice creates cliffs and valleys, and gravity pulls land downhill in landslides and mudslides. Erosion caused by wind and water created the Grand Canyon. So here we have what kind of looks like a drawing of the Grand Canyon. If you ever went out towards wherever the Grand Canyon is, maybe Colorado, but maybe also Arizona, one of the four corner states. This is similar to what you would see. Giant peaks of rock that you would be standing on, and way down below, the little river. Signs of erosion in Russia specifically. Much of Russia consists of vast plains. On the west side of the Ural Mountains is the Northern European Plain, and on the east side of the Urals are the West and Central Siberian Plains. Over millions of years, wind, water, ice, and gravity have worn away any high ground on these plains. The flat or gently rolling land of the plains that we see today is the result of this erosion. Many major rivers crisscross Russia's plains. One of them, the Volga, is Europe's longest river. Is Europe's longest river. I can read. The Volga wanders south across the northern European plain, carrying along many tons of sediment, oil, soil, and sand. When the Volga floods, it leaves behind the sediment on the surrounding land, a process known as sedimentation. Eventually, the Volga deposits any remaining sediment into the Caspian Sea, turning its waters a cloudy green. The Volga flows through the agricultural and industrial heartland of Russia. Almost half of the Russian population lives in the Volga River basin and relies on the river for power, transportation, and irrigation. No wonder Russians call the Volga Matushka, which means mother. The Amur River flows from the mountains of northeast China and through eastern Siberia to empty into the Sea of Okhotsk. Whatever. This sea is a large arm of the Pacific Ocean on the eastern boundary of Russia. For about 1,000 miles, the Amur River forms a natural boundary between Russia and China. Like the Volga, the Amur River has become an important part of Russia's economy. Frequent springtime floods have created flat and fertile floodplains along the riverbanks, making the plains a rich agricultural area. The Amur is also a source of transportation, with large boats traveling most of its length from May to November. The Lena River flows northward through Siberia into the Arctic Ocean. From above, this river looks like a black snake winding its way across the plains. In late spring, ice blocks the flow of water at the mouth of the Lena, causing water to back up and flood the surrounding land. How glaciation shapes the landscape. In the coldest places on Earth, large fields of winter snow becomes ice that remains frozen throughout the year. These masses of ice are glaciers, and they form over thousands of years as each new snowfall compresses the snow beneath into a dense ice mass. About 20,000 years ago, during the last ice age, glaciers covered 1/3 of Earth's land surface, including most of North America. Gradually, the glaciers retreated, changing the landscape as they moved. Today, glaciers cover only 1/10 of Earth's surface, but they can still shape the landscape in dramatic ways. Also, that's how our Great Lakes from Michigan were formed, or some glaciers. Fun fact! Geographers have identified two kinds of glaciers. Continental glaciers form in huge, thick sheets in areas with extreme cold climates, such as the two polar regions. Much of Antarctica, for instance, is buried under continental glaciers. The weight of the ice sheet eventually forces the edges of the glacier to push outward in all directions, in a movement scientists refer to as creeping. A second type of glacier, the Alpine Glacier, forms in high mountain valleys where snowfall is plentiful and temperatures are low. Instead of creeping outward, these rivers of ice slide downhill. As the weight of new snow and ice grows, the glacier is pulled down by the mountain by the force of gravity. Glaciers move very slowly, but they have enormous power. They can grind the hardest rock into fine soil and push great loads of rock and dirt across long distances. Continental glaciers erode land as they spread outward. As they creep, they pick up rocks and soil and pile them into mounds called moraines. Sometimes they leave behind finger-shaped holes in the land that become the lakes once the glaciers have melted. Hey, like I mentioned, the Great Lakes of North America are an example of lakes formed by the movement of the continental glaciers during the last ice age. Alpine glaciers reshape the land as they travel downhill. Sometimes they scrape away entire hillsides, turning rounded mountaintops into pointed peaks that are called horns. As they move down canyons, alpine glaciers carve narrow V-shaped river valleys into broad U-shaped valleys. California's famous Yosemite Valley was reshaped in this way by an alpine glacier. Signs of glaciation in Russia. Earth has experienced several long cold periods when glaciers covered vast regions. During the last of these ice ages, continental glaciers covered part of Russia. Although those glaciers melted as the climate warmed, alpine glaciers continue to exist in the high mountains. Both types of glaciers have left their mark on Russia's landscape. The Kolka Glacier of the Caucasus Mountains is located on Mount Kazbek, one of the highest peaks in the range. In 2002, ice from a glacier overhanging the Kolka fell, triggering an avalanche that slid more than 11 miles. The glacial debris dammed rivers, creating several new lakes. The Amanaz Glacier is located in the western Caucasus Mountains. As this glacier slides downward, it is creating a large valley between two jagged mountain ridges. And the Yamal Peninsula juts into the Arctic Ocean in northwestern Siberia. Continental glaciers once scraped across this peninsula, but today summers are just as warm enough to melt each winter's snowfall. The melted water then fills these holes left behind by the glaciers, creating glacial lakes. And here we have a picture of glaciers covering the Caucasus Mountains, and they've been here since the last ice age, 20,000 years ago. Alright, so in this lesson we learned how 4 physical processes, tectonic movement, volcanic activity, erosion, and glaciation, shape our planet. We read about how each process is at work on the varied landscapes of Russia. Tectonic movement is the slowest of these natural processes, but it has reshaped Earth's surface over time. Scientists believe that about 200 million years ago, all of Earth's land formed one huge continent. We call that Pangaea, or Pangaea, or Pangaea. Take your pick. During this period, the supercontinent, boom, Pangaea, broke apart into tectonic plates, and that's how we have our continents today. Go look up a picture. It was pretty cool. Scientists have studied the movements of these lithospheric plates form the continents we know today. Wow, I could have just read that sentence. Tectonic movement is still a powerful force at work on Earth's landscape. We feel the immediate effects every time an earthquake rattles windows or a volcano starts to release smoke. Over time, these events will continue to reshape Earth's surface. Crazy. All right, that is all that we've got for this lesson on Russia. Rather short, actually. It's only 13 minutes long. Crazy times 2. I apparently need to go take a nap because I am getting quite loopy. And on, what is today? Tuesday? So on Thursday, we'll have our final social studies lesson of the year. We're going to be talking about nation states from the old Soviet Empire and how have they succeeded. They left the Soviet Empire, became nation states. What's going on with them now? Why did they do that? And what helps a new nation state succeed or fail? And then we're done with social studies and done with Europe and Russia. Nice little cutoff at the same time. That will be for Thursday. So I will see you all then. Bye.